All right, let's continue from where we stop. Solubility. Solubility. Now, I asked a question from the beginning of this class. Have you come across the word solubility? What do you understand? I don't think any of you was able to explain what. I don't know. So, solubility can be defined as the maximum amount of what? Solute. Which can be in what? Gram or what? Moles. That can saturate what? 1 dn cube of a what? Of a solvent. At what? Temperature. What did you write? At that temperature. At a particular temperature. There. Particular temperature. There's calculation in this course, in this topic. So let's continue. Now, with this understanding, with this explanation now, what do you think the unit of solubility should be? Good. Mole per day cube is it can be a unit of solubility. What other units can you have? Good. Gram per day. What else? What other units can you have? Anyway, you have said the major ones, but you can have. You can have gram per day. You can have mole per day. Let's stop there. Maybe by the time we see questions, other things will start occurring. Other examples will start towards coming out. Now let's carry out a simple experiment. Let's describe a simple experiment on how to calculate solubility of a substance. I'll just have a rundown of a simple experiment to make you understand what solubility is what all about. Okay, let me describe an experiment. There's an experiment in this our reference textbook for today. It's just an experiment to determine the aim of the experiment. The aim, you can put down. Aim of the experiment. The aim is to determine the solubility of potassium triazonate in water at room temperature. Aim is to determine the solubility of potassium triazonate in water at room what temperature? Potassium triazonate in water at room temperature. From this aim now, which one is the solvent? Actually, from this experiment, this aim I said now, what is from this sentence I made now, which of them is the solvent? What is the solvent in that sentence?
The solvent.
The solvent. You're not clear?
No.
You said no. You know, yeah? Which one is the solvent? Do you truly understood what we talked about solvents?
Yes.
So what is solvency? What is solvent? I don't know.
Okay, meaning of solvent. A substance that dissolves in a solute.
Is that what I said here?
Yes.
Is that what I said here? You, what did I say about solvent?
Solvent is a substance that dissolves solute.
That dissolves solute. You are saying it's what that dissolves in a solute. Solvent and solute, which one dissolve in each other? Huh?
Solute is being dissolved
Where?
in the solvent.
What we in solvent. So that one that thing this which one is solvent? For my last statement now, which one is solvent and which one is a solute?
Solute is potassium triazole. Then solvent is what?
Why?
Because it's potassium triazole that is being dissolved
Dissolve where?
in the water
Good. Now, at what temperature are we looking at?
at room temperature.
What is room temperature? How many degrees Celsius? How many degrees Celsius is room temperature?
20,
You
25.
good. 25 degrees. So the room temperature is what? 25 what degree. Now, just listen to what I want to say. You may not necessarily put down everything, but just I want to explain something. The method for this experiment is that a boiling tube containing distilled water containing distilled water up to half of it, or start like this. Before you write in a boiling tube, put in before that a. In a boiling tube containing the distilled water to half of it, half of the boiling tube, right? Then add excess potassium triazole 5 and stir. A boiling tube that half of it is filled with to the half of it distilled water. Then you add what? Potassium triazole what? 5 and stir it for some time. You know what is stirring, right? Right? Good. You stir with a stirrer, right? And stir for some time. Now the next thing to do is that after stirring for some time, you watch it as you stir. You watch it as you stir. Then it will get to a point when the potassium triazole stops dissolving. Are we together? In a boiling tube, you stir a boiling tube that contains water. They say water half of it. You add what? Potassium triazole 5 and stir. But as you are stirring it, you watch. It will get to a point when the potassium triazole 5 will stop dissolving, right? When it stops dissolving, you filter the solution. When it stops dissolving, you filter the solution. I want to ask a question. Stop. Let me ask a question. So why do you think? What will happen when the potassium triazole 5 stop dissolving? What actually happens when it stop dissolving? Is what? So you have formed a saturated. Are we together? Now you filter the what? Solution. So after filtering the solution, the filtrate the filtrate itself, that filtrate you filtered, it's not the whole system. The filtrate is what is called the what? Saturated solution of what? Potassium what? Trihydrogenate what? 5. So the filtrate, after filtering it now, which one is the filtrate? Chinwe, if you get a filter paper and get a funnel and fold the filter paper and put it on the funnel and pour a solution, that solution you made into that filter paper. From the funnel, a liquid comes out of the funnel, right? While some will be on top, those that could not pass will be on top of the what? Filter paper. You have two different samples now. Which of them is this? Is the filtrate? Anywhere that pass through. Good. The other one is not the what? Filtrate. Am I communicating? Good. So let's continue. Now, this is the first step you take. The second stage now is this. That saturated solution. Put the saturated solution, pour some of the saturated solution into a weighing evaporating dish. Have you seen an evaporating dish before in your chemistry lab? Have you seen an evaporating dish before? You've not seen it before? It looks like small, it's a ceramic thing that is white, as small white. You can use it to heat something to evaporate. That's what is called evaporating dish. Now inside, you pour that what is called some of that saturated filtrate, not that filtrate. Do you know why you filter it? Because there's undissolved one there, true of us. There's undissolved particle there, true of us. So now that one you filtered, that filtrate is a what? Saturated solution. You now pour it in a what? Evaporating dish and weigh it. No, see what you do. You don't weigh it directly. See what you do. You know, have you ever tried? Do you know how they weigh liquid? How do they weigh liquid? Good. If you get the empty container, you weigh it first. Know the weight. Then pour the liquid. Then weigh everything together, right? After you subtract the weight of the container and liquid from the weight of the container alone, that what you get is the weight of the what? The liquid. Is it clear? Now that you want to know the weight of that what? Saturated solution. That's what you want to know. Now what you now do is this. We pour that saturated solution in an evaporating dish. First of all, you weigh that evaporating dish first. After weighing the evaporating dish first, you know the weight of the evaporating dish. Then after that, now you now pour the solution, the saturated solution, in the what? Evaporating dish that you have already weighed, and weigh again. You now note the weight of the what? Evaporating dish and the weight of the what? Saturated solution. After that, you now, whatever weight you get, you subtract the weight of the evaporating dish and the saturated solution. Sorry, you subtract the weight of evaporating dish alone from the weight of evaporating dish and what? Saturated solution. Whatever the difference you will get, the weight you will get will give you the weight of the what? The weight of the what? Saturated what? Solution. Now put down. Pour some of the saturated solution into a weighed evaporating dish. Pour some of the saturated solution into a weighed evaporating dish. Then weigh again and find the mass of the what? Saturated what? Solution. You weigh again and find the what? The mass of the what? Saturated what? Solution. Full stop. Now, just if I explain, I will tell you what to write. Just listen and understand. I want you to understand what I'm explaining. If I explain, if I wanted to write, I'll tell you what to write. Unless if you can put in down things on your own, but no problem. But as you put down something, don't make sure you don't do what? Lose focus. Because I may say something that will make you to understand that thing you see put down. Just listen carefully as you put down. Now, you have determined the weight of the what? Saturated what? Solution. The next step, remember, you have already poured it in what? Evaporating dish. So what you do is this, you heat that saturated solution in that evaporating dish. Heat it to dryness. Heat it until the water in that solution evaporates. And you have the dry potassium what? 395. Only solute. Good. Now the next thing is to do what? You can put down. Heat the solution to dryness on a water bath. On a water bath. You don't heat. You know what's a water bath now, right? Chiwe, you see water bath, right? Good. You don't heat. Have you seen water bath before? You don't heat the dish directly on heat. Don't put it in the heat. Don't get a Bunsen burner and put the dish directly. You get a water bath. A water bath contains water that is heated at a constant temperature. That is a water bath. You can adjust the temperature. If you want the temperature to be at 40 degrees Celsius, the temperature of the water bath will be just a box of metal or something that has water inside it, that has heater. But it will maintain at a particular what? The temperature of that water will maintain at what? At a particular what? Temperature. Do you know why you need a water bath? Remember we were talking about. Remember I tell you that solubility has to do with what? At a particular what? Temperature. Don't forget that. Now that's why you need a water bath. Now you heat the evaporating dish in a water bath. Good. He said that you should heat the solution of the dry. You heat the solution to dryness on a water bath. By dryness, it means that all the water content will do what? Disappear, right? Right? Good. Now listen carefully. After heating it in water bath to get dry, you bring it out. You cool the what will be left in the evaporating dish is what we call what? Residue. Residue will remain, and that residue is potassium nitrate, right? Residue will remain. You heat the residue. You cool down the what? Residue. Just listen carefully. You cool the what? Residue. Dry it in a desiccator. You know what a desiccator is? A desiccator is an apparatus used to do what? Dry samples, right? Make it dry, total dryness. So that solute, that residue you got after evaporating in a water bath, you cool it down and do what? Dry it and weigh it again. If you weigh it, what do you want to achieve by weighing it? Let me know someone that thinks. If you weigh it again, what do you want to achieve by weighing it?
To know if it's the same amount.
To know what?
If it's the same amount.
To know what? Sorry.
If it's the same amount.
I don't understand what you mean.
Like when you subtracted it from the weighing, then now you get your answer now.
Remember, you have already known the weight of the what? The weight of the what? The weight of the what? Saturated solution by when you put it in the what? Evaporating dish, right?
Yes.
Now you want to know if you already know. Remember before you started heating to dryness, you already know the weight of the what? Saturated solution, right?
Yes.
Now, if you have noted that weight of saturated solution you got by subtracting the weight of the evaporating dish plus and the weight of the what? This thing. You have already noted down the weight of the saturated solution. Now, if you heat it to dryness and weigh it again, you want to determine the weight of the solvent. that left the what? Solution. Remember we said that solution has what? Solute and what? Solvent. And the solute there is what? Potassium what? Nitrate. And the solvent is what? Is what? Water. When you heat it, what disappears? Chinwe. When you heat it, what disappears?
The water.
What disappears now? So if you check the weight after heating to dryness, what do you want to determine?
The amount of the solvent.
That left, which is always sent with the amount of solvent in the what? Solution, right? Good. That's what you want to determine. You know that particular weight. How many weights have you rated now? Weight of the evaporating dish is there. Weight of this saturated solution is there. And weight of the solvent that left is what? There. Now, of course, are you aware that if you weigh the residue in the evaporating dish, you can determine the weight of the residue? Are you aware? By subtracting the final weight you got, subtracting the weight of the evaporating dish alone from the weight of that residue in the what? Evaporating dish. You know the actual weight of the what? Residue. Are you aware? Let's keep going. Now, so you will not ask, have you put down this one that you cool and dried residue in a desiccator and weigh again? Have you put this one down? Have you?
No.
Are you with us? No, you are not. Please let's focus. If you are someone teaching you and ask something, ask a question, reply. Show that you are following. Don't keep quiet, please. Now you cool. I said what you put down now is this: cool and dried residue in a desiccator and weigh what? Again. Cool and dried residue in a desiccator and weigh what? Again. Then the next thing is to find the mass of the solvent that was evaporated. So, how do we find the mass of the solvent that was evaporated? How? Tell us, Chinwe.
By heating the solution.
You have already heated it now. You have weighed it and so okay. So sorry. Continue.
By heating the solution in water phase for dryness. Then, if it's dry, you now weigh it to know the amount of the solvent that left.
So how will you now do it? How will you now get the amount of solvent that left, the weight of solvent that left? How will you now do it?
By calculating the amount of evaporating dish. And the residue.
By doing what?
Calculating the amount of evaporating dish and the residue.
How do you determine the weight of solvent that left? That's the question. How? How?
Weight of the residue minus weight of the unsaturated solution.
You simply do, you know that you are going, okay, let's start from the beginning. How do you determine the weight of the saturated solution? Chinwe, tell us. How do you determine the weight of the saturated solution?
You weigh the container.
Which container?
Evaporating. Then you pour the liquid, that's the saturated solution. Then you weigh the both of them. Then you subtract the weight of the evaporating dish and the
From mark your words well, please.
From the saturated solution to get the amount
of what?
Of the salt of the
of what? Solvent. Why? To get the amount of what?
Of this solution.
Good. To get the amount of the what? Saturated solution. Now that you have known the weight of the saturated solution, what else are you going to do?
Then you now mix the solution
In the dish, right? Then if you heat it, what happened?
to dry.
Why did it dry? What happened in the drying it? What actually happened there?
Because of the temperature.
What happened in the dryness? Now, what happened to it for it to get dry? What exactly happened for the dryness to occur? We know you heat it, we know, but what happened? What change happened in the solution? Solvent left now. What are you even doing? Solvent left. It's not true.
Yes.
Didn't you understand this when I was explaining it? Didn't you? Then what's going on now? Now, you hit it, then the solvent will do what? Will leave, true of us. Now, how do you not determine the amount of solvent that left? That's the question.
You weigh it again.
You weigh what?
You weigh the separated solution.
Again, how?
Like the solution that you get,
From where?
that the residue that you
You're still missing up this is why. Isn't it you don't understand there? Why are you missing up things like this now? Please see. That's how I do in my class. And you don't understand, tell me you don't understand it. Don't keep quiet about it. I don't like it. Tell me I don't understand this thing. I will explain it. That's why we are here, not else. We are not here to show that we are here to learn. And you don't understand. Once I mention it, you don't understand. You say I don't understand it. I will explain it. I don't understand why someone will understand something. You can't talk about it. It doesn't make sense to me. If you don't understand, say it. I don't understand. I will explain it. Now you said you have gotten the weight of the what solution, right? Now you say you heat it. So after heat it, what happens? When it dry, what made it to dry? What happened? What changed that occurred for it to dry? The solvent left now. Oh yeah. Continue.
then the residue will remain.
Good.
Now wait again to know the weight of the solvent that
How do you check it? How do you know the weight of solvent that left? What are you weighing again?
the residue.
Then how do you now determine the weight of solvent that left?
Then the evaporating dish plus the weight plus the residue.
You say what? You do what?
By adding the evaporating.
Add what? What are you saying? How did you get the weight of this solution in the first place?
By subtract.
So what are you going to do now?
Okay, now subtract the evaporating dish from the residue.
Subtract what?
Evaporating dish.
How? What is a solution?
For example, the solution is solid in
What does the solution contain?
solute and solvents.
Then you get the solution and heat it. Solvent left, solute remain. I'm not asking you, how do you now determine the amount of solvent that left? It seems that you are adding solute again, and what are you adding again? Here contain two things. You heat it, one left. You get 4. Now you want to know the amount that left. What are you going to do? You minus what?
You minus the residue and the solute.
How? You minus residue and solute. How? What is solute? What's residue?
Residue is the
Is residue not the same thing with the solute? Is it not? What is residue? Residue is gotten from where? Is residue not the same solute in the solution? When you hit a solution and the solvent left, what remain?
The solute.
So is that not the residue you're talking about? How come you're adding residue and the solute again? So what are you going to subtract? That's the question.
The weight of the solvent and the
Solvent. I don't think you understood what I explained here. You don't understand. Did you understand what I explained here since? Did you understand this? You are confusing this whole thing. What is a solution, Chinwe? Tell me what is a solution.
The solution is.
Calm down, relax. Tell me what is a solution.
A solution is that resulting in substance.
Forget that long story. Just tell me what it contains.
Solvent and solute.
So if you hit solution, what will happen?
It will cry.
In Agogo Greek, what will happen if you hit a solution? What will happen?
It will this solvent
We do what?
will evaporate.
So what will remain?
The solute.
The solute. So how do you now determine the solvent that left? Weight of solvent that left. Look at your work. How do you determine the weight of solvent that left? You said you dry it, you heat it to dryness, you cool it, and weigh the what? The residue that remain. Remember, you already know the weight of the solution. You kept it, and you heat it to dryness, and you cool it down, and you weigh what is remain. How will you determine the weight of what left from that solution?
By subtracting the
By subtracting what?
the weight of the solution.
If you are in a lab as a performance technician, you are in a lab to prepare this thing. Now, what are you going to do? That's the question I'm asking you. You want to know the weight, what was this? This is in a dish, in a pot. Ima the weight of what is inside this pot. Ima the weight before it hit beer. Milliposiania. Ye fozebo solute. So no fozenia. Ije weigh nua. Maluku take a weight nua. Before it hit beer, ima the weight of the solution. Now, how will you not determine the weight of soil that left? That's the question.
The solution minus the solute.
What solution? The solution. Be specific.
Potassium.
The what quality of the solution? What?
The saturated solution.
What are you weighing? What are you talking about? You can't tell me the solution. They know. What is it? The length or the width or the volume? What are you checking?
The volume.
Is it the volume you are checking here? I'm not asking you. Keep quiet. I know you know it. Oh yeah. My class, everybody in my class must know something. I don't believe in. Oh yeah, now as a question. I don't teach like that. So what are you going to do? What exactly? Speak like scientists. Don't telling me solution. The weight of the solution. Subtract the weight of the solution, the weight of the solute or the residue from the weight of the solution. You get the weight of the solvent. In our totally here, you're a science student. Please speak like one. Be bold and think critically. This thing is a simple thing. You should relax and think about it and know how to go about it. Rational thinking. I'm sitting here, it's not what thing. I just say, let me even ask a question. I'm okay, but Afuna, what's going on? Shall we continue? So tell me again what I said now. How do you determine the weight of the solvents that left the solution? Oh yeah. Describe it.
The weight of the solution minus the solute. The weight of the saturated solution minus the solute.
Minus solute. How? Minus what? Minus solute.
Minus the residue.
Minus
the solution.
Minus solution. What are you even saying, Chinwe? Are you okay with us? Are you with us here now? You see, seem the weight of a minus solute. Minus solute, what solute are you what parameter of the solute are you subtracting? Is it the volume or the weight or the length? Speak as scientists, please. They are nothing like the weight of the solvent solution minus solute. What is solute?
The weight of this of the solution and the weight of this.
Of what? You are still confused about this thing. Are you sure you understood this thing? No, you don't.
The weight of the solution minus the weight of the solute will give you the amount of the solvents that left.
Good. Now, let's start from where we stopped. Now, so you now know the amount of this thing that was what? Because they said find the mass of the solvent that was evaporated. So we will now know how we can determine the amount of the solvent that was evaporated, right? Now, and hence the amount of solute that dissolved in that amount of the what? So are you aware? Listen carefully. I want to say something again now. Listen carefully. If I say listen for real. Stop what you're copying and listen. Because if you understand what I'm explaining, there's no way you can even put it in your own way. But the most is to understand what you are doing, what explaining. Now, there's a point I made now. I said, find the mass of the solvent that what evaporated, and hence the amount of solute that dissolved in that amount of the what solvent. I mentioned this thing before I started asking you a question. I'm going to ask another question there again. If you're in my class, your mind should always be there. You got really attentive, because I keep making points that link with each other. Let me go back again. I said, I think I called this one out, right? Find the mass of the solvent that was evaporated. You have written that one down now, and you know how we got that one. Then and hence the amount of solute, that dissolved in that amount of what solvent, and hence the amount of solute that dissolved in that amount of what solvent. How do you determine the amount of solute that dissolved in that amount of solvent? How do you determine the amount of solute that dissolved in that amount of solvent? They are asking you the weight of the residue. Simple. So how do you determine the weight of the residue, Chinwe? Are you Chinwe? So tell me, how do you determine the weight of the residue? Tell me. How? How do you determine the weight of residue?
The weight of the solute plus the weight of the solvent.
More about Jogi, how do you determine the weight of residue? You say weight of solute plus weight of solvent. What are you talking about? What I say? I say, let me hear you. How do you determine the weight of the residue?
Weight of the residue minus weight of the evaporating dish.
The same?
Weight of the residue minus weight of the evaporating dish.
Asking how do you determine the weight of residue? You ask weight of residue minus weight of evaporating dish. You know here? Actually, over back to you. How do you determine the weight of the residue? This thing is there in that thing you are looking at for the past 20 minutes. Just to articulate your mind and answer that question. It's there looking at you. It's just critical thinking that will solve this question. And this is what I want to train people to start thinking. Start thinking critically. So how do you determine the weight of residue?
By heating the solution.
Solution you have already heated. Which other solution are you heating again?
But it is said that the residue was weighed after cooling the residue.
Weighed where? Did you carry it in your hand and weigh?
Evaporating dish.
So how do you determine the weight of residue now?
We minus the weight of the evaporating dish from the weight got after the cooling of the residue.
How do you determine the weight of residue now? Huh? Huh? No idea. Okay. Describe again how you determine the weight of the solvent. I'm asking you that question now. Describe again how you determine the weight of the solvent from the beginning. Remove your hand and start sit where talk.
You minus the weight of the solution from the weight of the solvent.
What are you saying?
From the weight of the solvent.
I ask, how do you determine the weight of the solvent? How do you determine the weight of the solvent?
By subtracting the weight of the solution from the weight of the solvent.
What are you even saying? Weight of solution and weight of solute can get say canon. How is subtracting solution from solute? What are you even saying, Chinwe? How do you subtract? How will you subtract solution from solute? Solution and solute can get say canon. Solute get solution. Or solute no didn't solution because solution didn't solute. Megan, qu'est-ce que c'est solution? Wait, wait, solution.
Weight of the solution minus
What of solution minus what of solute? You get what?
the weight of the solvent.
Now, how did you determine the weight of that solute? I say describe that experiment again. I want to point out something. There's something I want to point out. That's why I'm asking that. Just by the time you describe it now, you answer this question yourself. That's why I want you to answer it yourself. That's why I say go back again. Describe what happened. You will start from the beginning of the experiment. You weigh the empty evaporating dish.
Then you pour the liquid.
The what?
The liquid.
Which liquid?
The solvent.
Which solvent again?
You weigh the evaporating dish.
Uh-huh.
Then you pour the solution.
Which solution?
Potassium carbonate.
Saturated solution.
Saturated.
The one you filtered out.
Yes.
Uh-huh.
Then you weigh the both of them.
Mm-hmm.
Then you subtract the weight of the evaporating dish from the saturated solution.
So from where?
From the solution.
Again, measure.
To get saturated, to get the amount of saturated solution.
Mm-hmm.
Then you heat the solution
Mm-hmm.
in a water plate for dryness.
Mm-hmm.
Then after drying it,
So what do you? Where I echenaka where heat here?
no,
Kebo the way heat here.
in evaporating,
So if you after heating it, what happened?
then the residue will remain while the solvent will.
So how do you determine the weight of the solvent?
Weight of the solution minus weight of the solute.
The solute the echenaka we check here.
No, in evaporating.
Did you check the weight of the solute in the evaporated dish?
After then the residue will remain. Then you weigh it again to know the amount of the solvent that left.
So after weighing, what happened? What is the weight of the solute you say you weigh you dry it. It's still in a evaporating dish, right?
Yes.
Then you weigh that thing you weigh. Is it the weight of the solute or weight of the solute and evaporating dish?
What I mean?
What you weigh to determine the weight of the solvent that left? The dry one you weigh now is weight of what and what?
Evaporating dish and the weight of the evaporating dish and the residue.
Good. Now, Jessica, what is the weight of that solute? How did it determine the weight of the solute now?
Evaporating dish minus.
Stop mixing up things. Speak like a scientist, please. Speak like a scientist, please. Stop mixing up things.
Evaporating dish minus weight of the solvent.
Solvent from where? Remove that thing from your mouth. When you have weighed this thing and you weighed something in a evaporating dish. You said you weighed the residue, right?
Yes.
To get what?
The weight of the solvent.
Now that residue you weighed, is it the weight of residue? What is residue?
The products that.
Is it the solute or what else can you call it? The solute. Good. Is it what that thing you weighed? Is it only is Shanaka Wale weighing?
No.
So what weight did you record actually?
The weight of the evaporating dish and the solute.
You say what is the weight of the solute? That's the question that you see ever. How do I determine the weight of that residue alone?
Evaporating dish minus.
Speak like a scientist.
The weight of the evaporating dish. Minus the weight of the solute.
It seems you don't know your science well. I think that's where this problem is. How can you be subtracting weight of solute from weight of evaporating dish? How? Organize your thought well and answer this question. We are almost at the end of this. Organize your thought well and answer this question. How will you determine the weight of the solute alone? How? What are you thinking about? You are the one that told me that the solute is in evaporating dish. You dry it there and weigh it. Which weight did you record? You said what?
Of the solvent.
Solvent what? When you weigh the evaporating dish, when you weigh the solute, you dry the solute in the evaporating dish. What weight did you record?
When I weigh the evaporation, the weight of the solvent that left.
Just tell me how you determine the weight of the residue. That's what I'm asking. How you determine the weight of residue now?
The weight of the evaporating dish. Minus the weight of the separated solution.
Weight of evaporating dish minus weight of saturation. So what will you get?
The weight of the residue.
How? How will the weight of evaporating dish minus weight of saturation give you the weight of the residue? How? Huh? How? Huh? I'm listening. So how? Children, what is the weight of residue? I'm not joking ever since you. I'm not coming here here. What is the weight of residue?
The weight of the evaporating dish minus the weight of the solid.
The weight of evaporating dish. Weight of evaporating. Asking what is the weight of the solute? You ask what is solute? Solute and residue are they different things? You see, weight of residue is come. It has to come with weight of evaporating dish minus weight of residue. You're confusing me here. Are they different things?
Weight of the evaporating dish minus the weight of the solvent.
Echi residue n'aka were ewe ya ka ebi tinye were ewe ya. Sit well. Echi n'aka were ewe ya. So where are you weighing it?
The evaporating dish.
So what is the weight of the residue?
Weight of the solvent minus weight of the evaporating dish.
Echi residue n'aka were ewe ya ka ebi tinye were ewe ya.
Inside the evaporating dish.
So what is the weight of that residue you are weighing? Huh? Did you weigh the evaporated dish at all? Then what is the weight of that solute? Huh? Huh? You weighed this dish alone. You keep the weight. You put you dry this thing, the solvent left. You weighed the residue in the dish. The weight is there. You just like go to residue since you know I not going to get. I'm disappointed, though, seriously. I am. You said you weighed evaporated dish and kept the weight, recorded the weight. You hit the heavy thing, the solvent left. Good. You told me how you got the weight of solvent. Perfect. Now you told me again that you even before you got the weight of solvent, you also weighed the residue. Njogi, how did you weigh the residue? Did you weigh it in your hand? The same, not the one made that evaporating dish. Fine. This is like, what is the weight of that residue remaining for the past 30 minutes? Chinwe? Plus what? Plus what?
Plus the weight of the solute.
The measure.
Then we get 100.
Please tell us how to get weight of solute, please. All right. Weight of what? How? Now what?
After the residue was cooled, it was weighed inside the evaporating dish. Then the weight got minus the weight of the evaporating dish.
That's all. You have the evaporating dish. Just when you heat everything, the thing is still in the evaporating dish. You weighed it, and what you weighed out is that weight you got is with the weight of both the evaporating dish and residue that's remaining. So if you want to get the weight of residue, you simply do what? Subtract the weight of the what? Evaporating dish. And you get the weight of the what? Residue. That's what they are trying to let us know, that you should do what? And hence the solute. And that residue is the what? The solute. So the solute that was actually dissolved is the weight of that what? Residue. That was the one that was actually what? Dissolved. See what I said now. Oh yeah. See what I said now.
He said that the residue is inside the evaporating dish. So you might not
Sit where, please.
you might not sit from the evaporating dish.
You will not swallow what from the evaporating dish.
The residue.
Did you understand what to explain now? And you kept quiet. That's the problem. I don't like this. I don't like it. I don't like it. My students should be outspoken. Immediately you don't understand anything, don't allow us to go into nothing. Call the attention of my attention immediately. I didn't get what you said. Nobody will beat you. Nobody will slap you. Nobody will. What angers me is that You will keep quiet. I will teach you. When I ask questions, you're looking at me as if I'm talking trash. It's annoying and I don't know how to put it. But if you call my attention, I wouldn't mind. I will keep explaining because you're here to learn. But what I don't like is this: you keep quiet for what you don't understand. I don't like it. You know me for that from school. You know me for that. Two of us. I don't like it. Once I teach, once you start missing out, call my attention immediately. Even if you can remain here for 2 hours, I don't mind teaching it until you learn that thing. But what annoys me is you keep quiet. You didn't understand it. You keep quiet, as if you understood it. You're writing what you don't know on your paper. Then at the end, when I ask you a question, you're looking at me as if I've been wasting my time. It's annoying. I put so much energy to do this I'm doing. When my students don't understand something and you keep quiet, and at the end, I realize that you didn't understand it and I keep quiet, it makes me feel as if I am wasting my time. I don't like such thing. Now let me explain this. Do you think I can regret for you that you didn't understand anything from this time we're talking about this experience? Only what I know. That was why I took you back from the beginning. That's why I took time with you here to train you because I'm not happy that I was explaining something you don't know, you kept quiet. Now, what I want to say is this. It's so simple. This is a dish. Is it because of the too much grammatic scientific name we call all those things that make it to look as if it's difficult. Just get a plate or cup. Let me say a plate, a stainless plate, or any pot, even pot, small pot. Name the pot. You need that saturated solution. First of all, you prepare the saturated solution by what? I told you what a saturated solution is. I hope you listen to me. Good. I tell you what a saturated solution is. That a saturated solution is one that has taken the amount of solute it can carry, and it cannot carry any other solute. In the presence of the undissolved one, there are still one undissolved one present. That's what a saturated solution is. And I'll say that if you get potassium 2025 and pour it inside water, as you are pouring, you are stirring hot, boiling tube that has filled to the half of it with what? Distilled what? Water. As you are pouring it, you are stirring it, and as you are stirring it, it's going to a point, this potassium 225, that is the solute, will stop what? Are you following me? Yes. Will stop what? Dissolving. At that point, it stopped dissolving. The solution has become what? Has become what? Has become what? Why do you keep quiet? Has become what? Saturated. Now, because it has become saturated, it cannot take in anything again, right? Once you reach that point, they say you should do what? Filter the solution, right? If you filter it, the filtrate you got, that is actually the what? The saturated solution. Is that filtrate that you pour in an evaporating dish. But before you pour it, you weigh the what? Evaporating dish to know the weight and write the weight down. Then you heat that saturated solution in the evaporating dish on water bath to maintain the what? To maintain the what? Temperature. Now, if you heat it until it becomes dry, only the residue will remain. That means the solvent will do what? Go. You are asked to remove the what? Petri dish or the evaporating dish or the plate, whatever, that contains that what? Residue, and put it like that. You don't remove it from it. Put it like that in a desiccator to dry it completely so that there's no moisture at all. You bring it out. Carry it with the same evaporating dish and go and weigh it As long as you put it, they didn't say you should remove it with the hand and go and weigh. They say you weigh it in that evaporating what? Dish. I now ask a question. How do you determine the weight of solvent that left? It's simple. The weight of that solution, if you want to know the weight of solvent that left, the initial weight of that solution, saturated solution in that dish that you weighed before, right? That weight in that dish that you weighed before, minus the weight of that residue in the same dish that you got, will give you the weight of solvent that did what? That did what? Left. I now have this last question. What is the weight of that residue? It's also simple. Since you carried it in the evaporating dish, whose weight you know before, that didn't change. The weight of the evaporating dish is accepted. Simply subtract the weight of the evaporating dish, empty evaporating dish. You check the weight before. Subtract that weight of the evaporating dish from the evaporating dish that the weight of the residue you check later, which is weight of the residue itself and the what evaporating dish. Once you subtract the weight of evaporating dish from the final weight you got, the weight that you made is weight of the what? Residue. And is this weight of residue, which is solute, that is contained in that what? Saturated solution. Do you know the meaning? That is the maximum amount you can do what? You can dissolve. Perfect. That weight is your maximum amount that solvent can take. If you want to determine the solubility of potassium nitrate, see what you will do. Since you have known the weight, the maximum it can take, which is the weight of the residue, right? Do you know the volume? You can note the volume of the solvent. Did they tell us the volume of the solvent? But they told us the weight of the what? Solvent. Convert weight of the solvent to what? Volume. If you convert, how do you convert the weight of water to volume? 1 gram of water is equal to 1 what? Cm cube. You know that one. 1 gram of water is equal to what? 1 cm cube. So if you know the weight of the solvent, which is what? Water, which is 1 gram, which is in gram. If 1 gram of water is 1 cm cube, what will you do? That gram, you convert that gram to what? Cm cube, right? And know the what? The volume in what? Cm cube. Once you know the volume in cm cube, you have known the volume of solvent. How did we define solubility? We said that solubility is the maximum amount of solute a solvent, 1 dm cube, right, of solvent can take, right, at a particular what? Temperature. You have known the volume in cm cube. If you know the volume in cm cube, how many cm cube are in 1 dm cube? You should know that one. How many cm cube are in 1 dm cube? There are 1,000 cm cube in 1 dm cube. Can you remember now? Now, if there is 1,000 cm cube, 1 dm cube, you now look for it in dm cube, because you have known the amount the water, the solvent can take in that cm cube you calculated, right? But you don't know the amount you can take in dm cube. You convert it to what? Dm cube. So let's assume that volume we got for water solvent is 20 cm cube, for example. Now maybe 20 gram of what solvent left, right? Therefore, how many cm cube left? Let's assume 20 gram left. How many cm cube left? 20 cm cube. Now 1 gram is, put it down. 1 gram is 1 cm cube. This is how to learn. Put it down. 1 gram is what? 1 what? cm cube. It's not true. And 1000 cm cube is 1 what? dm cube. I don't know if people are, please, if you are lost, let me know where you are lost. Don't keep quiet and looking at me like that. If you are lost, let me know where you are lost. Are you lost? Tell me. Because I'm about to prove something that will help you to understand calculation in what? Solubility. That's what I've been trying to do here since.
1000 dm cube.
1000 cm cube is 1 dm cube. Are you aware that you can also define solubility as the maximum amount of solute that a solvent can take? Are you aware that you can also define solubility as the maximum amount of solute 1000 cm cube of a solute can take, of a solvent can take at a particular temperature? Can you define like that? Can you? Because 1000 dm cube is 1 cm cube is 1 dm cube is 1 dm cube is how many cm cube? 1 dm cube is how many cm cube? 1 dm cube is how many cm cube?
1000 cm cube.
I said 1 dm cube is how many cm cube? 1 dm cube is how many cm cube? Because I first told you that 1000 cm cube is 1 dm cube, and I ask you again, 1 dm cube is how many cm cube? You don't know what to say again. Because I changed it. Hey, but it's okay. I just want to. Actually, I can't put it brain. I want you to stay alert, to think alert. I want you guys to just be smart in thinking. When it comes to this type, all these things, be smart in thinking. That's what I want to achieve, nothing else. Asking that 1000 cm, asking that 1 dm cube, asking that 1000 cm cube is asking that 1000 cm cube is 1 dm cube. It's like 1 dm cube is how many cm cube? You see, it must be because now because I started with cm cube now. But it's okay. We are here to learn, sure. Now, do you really understand where I'm going to now? But this I'm explaining. Don't worry. After I will use mathematical reason to explain this. But why I want to, if you understand this way, this thing the way I am saying it, there's no question you see you cannot answer. That's why I'm taking my time like this. Taking my time like this. Defocused, because it seems you got distracted at a particular point, and I don't want it in my class. Now, I said, let me get to that point. We agreed that point, that the amount, that solute that remain, that amount of solute that remain is the amount, the highest amount that thing can take, that solvent can take, right? Which is water, right? Let's assume we got it at maybe 10 grams or something, no matter what it is. But just know that weight is the maximum you can do what? Take. But remember, we define solubility as the maximum amount of what? Solute. 1 dm cube can do what? Take. Now, that solvent that left is this amount of solvent that could take that what? Solute, right? Good. The amount was weighed. The solvent amount of that solvent is a gram, right? Now, I'm not asking you. And I told you that 1 gram of water is what? 1 cm cube, right? So if 1 gram of water is 1 cm cube, let's assume that the weight of the water that left is 40 grams, for example, or 20 grams. That means what is the volume of water that left?
40.
You. 20 cm cube. That is, let's assume it was 20 grams, right? That means it's what? 20 cm cube of water that what? Left. Mana, you cannot use it to divide the weight of the what? Solute. Because that one is in 20 cm cube. Oh yeah. Mana, for it to be solubility, the volume should be what? In what? 1 dm cube, which is in what? 1000 what cm cube. So if there is a specific amount of that, if that maximum amount of potassium nitrate is in 20 cm cube, how many will be in 1000 cm cube? You do what? Cross multiply. That amount of potassium nitrate that can dissolve in 1000 cm cube, maximum that can dissolve in 1000 cm cube, that amount is the solubility of what? Potassium what? Nitrate. Is it clear? Is it clear? Is it clear? Okay, then about before the clear. So far, no matter about. Get a Columbia. When you what about soon not probably maybe if I don't ask question, you carry it and go home. In China, yeah. Put a native here, accusing go town. When I'm no, that I just spoke to myself. I'm not here to show you that I know it. I'm here to make you to do what? Know it. That's why you are here. So if you are here and I rap from morning till night, after rapping, in Maria, as in if I'm here, rap from morning till night, after rapping, don't know it. What did I do? I wasted my time and collected your money. True of us? True of us? So I don't live my life like that. Okay, I want to give some figures now to this thing I've been saying since. I think I've explained what enough, right? Let me give you some figures so that you can. I will drive it at home. I have dragged you people enough now. I believe that there's no way, no place in your life after dragging you like this, they will mention solubility. You will know what to say. Is it possible? It's not true. It can never happen. At least you will have something to say. Even if you forgot something, remember how I dragged you. Speak a chinwe. Remember how I dragged you today. You remember how I dragged you. You remember it. I'm able to say something. That's why we are here. Now, let me now use some figures to explain this. Now, let's assume that remember we said that we weighed what is it called again? Remember we said that in that tube, right, that has distilled water, right, as we are turning into, we are pouring the what? Potassium nitrate, right, until it stops dissolving, right? Then we now filter. That one we filtered out. The filtrate is the what? Saturated solution, right? Good. Saturated solutions. Sorry, our reference book for today is New School Chemistry for Senior Secondary School by Osei Ababio, as reversed by L.E.S. Apanisi and Herbert Igwe. This one is 2016 edition. This is our reference book. Now, we say that when we now filter it, the filtrate is a what? Saturated what? Solution, right? Now, that saturated solution, we don't know the weight, right? So what do? What we did was to do what again? To weigh an empty what? Petri dish. Weigh an empty what? Petri dish or evaporating dish. Now let the weight of the evaporating dish be, let's say, let the weight of the evaporating dish be weight of what? We are doing calculation now. Weight of what? You cannot see it. Okay. Hey. No, this marker is writing well. Okay, see this one, right well. Can you see this one? Can you see this one? Good. Now, we are doing calculations now, okay? Now, weight of evaporating dish. Is what? Let's say it's what? 10 grams. Let's assume it's what? 10 grams. Are we together? Let's assume it's what? 10 grams. Then, we recorded it. and we pour that saturated solution inside the petri dish and weigh again, right? So weight of evaporating, I'm coming, dish plus what? Plus what? Saturated potassium what? Solution, right? Is equal to what? Let's assume it's 65 point what? Can I see board? Let's assume it was 65.27 gram. Let's assume it's what? 65 point what? 2 what? 7 gram. What this means is that weight of the what? Therefore, the weight of the what? Weight of the saturated solution, right? Potassium nitrate solution is now equal to what? This minus what? 62.27 gram minus what? 10 gram, which is what? 55 point what? 27 gram. Is it clear? Now, next thing we do, after that, what else did we do? That's saturated solution in the evaporating dish. We heat it what? We heat it, right? To dryness, right? Now, after heating it to dryness, we check the weight of we check it again. So what we now got is that weight of evaporating dish up here, plus the what? Residue or the what? Solute is equal to what? Is equal to what? Let's assume we got 12.87 what? Gram. Let's assume we got, after heating it now, let's assume we got the weight of evaporating dish and residue to be what? 12.87 gram. Then, what do you think should be the weight of the dry residue? Wait, first of all, what do you think should be the weight of the? Remember, after heating it to dryness, we cool it, right? And put it in a what? Desiccator for it to be dry, right? Then after drying it now, what do you think should be the weight of the solvent that left the what? The petri dish. So that means weight of the solvent, which is water, right? True of us, is equal to what? Tell me what you should be the weight of the solvent, Chinwe. From these figures we put down, what should be the weight of the solvent? Don't fail me this time around, you fail me the other time. This time around, you should be able to, since I'm writing on the board, you should be able to answer this situation now. What should be the weight of the solvent now?
The weight of the solvent.
Mm-hmm.
Okay. The weight of the solution minus the weight of the solute.
So what is it here? You are still mixing up this thing. Stop saying weight of solute. You're making this mistake. Look at the board and tell me the answer on the board, please.
65.27.
What does 5.25 represent?
The weight of the saturated solution.
Is that what I wrote on the board?
Weight of saturated potassium triazoxide.
It is a fuso. Don't this what's on the board. This is 2.5. What did you present on the board? Don't you see the board?
Weight of saturated potassium triazoxide 5 solution.
Chima, what is going on with you? No, for real, just apart. What is happening to you? I don't understand you again. Serious. What is happening to you? This is common sense can answer this question. You do need chemistry to answer this question on the board. 62.75 is what? 0.27 is what? Gram is what?
The weight of the solution.
My God. Stand up. Stand up. Go to that board. See 2.27, 12.7 is what on the board?
Weight of the operating was saturated.
Go and sit down. What are you thinking? You are not here, seriously. Where are you? Now, continue what you are saying. Stop looking at that book. Look at the board, please. Look at the board. Stop looking at that thing you're looking at. Look at the board. Answer the question on the board. What is the weight of the solvent from this thing I wrote now on the board? Any other thing we are going to write here now must come from this 1, 2, 3, 4. Three of us. So tell me, what is weight of the solvent now? Stop looking at the book. Look at the board and answer it from the board.
65.2.
What is 5.25?
Weight of the operating was saturated potassium trioxide.
What else?
Solution. Minus the solute.
Minus what?
The solute.
Equal is in a query. Then a board. Look at the board. Answer your question on the board.
Minus 55.27.
Minus what?
55.27 gram.
Hi.
Minus 12.87.
Minus what?
12.87.
Minus what?
12.87.
What is 12.87 gram?
The rate of the evaporating plus the restriction.
So what will it give you now?
To give you the weight of the solvents.
I hope you not just put. I hope you understand what you are saying here.
Yes.
You don't just because at this. You don't just put it because this one will not work.
No.
I hope you don't just say 12 because this one will not work. Okay. Then minus what? 12.78 gram. So what's the answer? What's the answer?
49.4 gram. 49.4.
49.4. How?
62.2.
Is this sorry? Yeah, this is 65, not 62. Sorry, this is 65, not 62. See it here now. Sorry. What's the answer?
52.4 gram.
50 what?
52.4 gram.
Check it again, please.
65.27 gram is 12.87.
Is what?
52.4.
$50 what?
2.4.
Okay. Oh yeah. 52 point what? 4 gram. Okay. So this is the weight of the what? Solvent alone. Now, Now, the next thing to determine is what is the weight of the dry residue? Good. Dry residue. Good. What is the weight of dry residue? Dry residue or the solute is what? Oh yeah, tell me.
10 grams minus.
It's not again. What I see. It's not again.
Weight of the evaporating dish minus weight of the evaporating.
So up to now, you can equally up to now. So up to now, you are not even corrected yourself. After 30 minutes of questioning you here, you are still saying something. You are saying that time. Can you about 10 grams minus what? What are you? This is an empty evaporating. What are you saying from empty evaporating dish? What are you even saying? This same thing that you must say correctly. You are still saying it now. So that means never waste or what? What do you see in this empty evaporating dish that you keep saying 10 minus? What are you minusing from it? Are you minusing from it or you should minus from something else? What are you even saying?
From something else.
Tell me what you should do. Oh yeah, what is the weight of that dry residue? Oh yeah.
65.27 grams.
Minus again. What are you saying? Chinwe, what is the weight of this dry residue? Okay, again. What is the weight of the dry residue? That's the question.
Minus 10 grams.
12 point what?
87 grams minus 10 grams.
12 point what?
87
Minus what?
10 grams.
Is what? The answer is what?
2.87. 2.87. 87 grams.
2 point what?
87
2.87 what? Gram. This is the weight of the what? Dry residue that remain. Remember I told you guys that actually this dry residue that remain is actually the maximum what? The maximum what? Weight. The maximum amount of what? Solute that the what? Solvent can take, right? Now, what solvents? What is the amount of solvent that can take this amount of solute? What's the amount of solvent? You know, what's the amount of solvent that can take this amount of solute? Tell me. I'm a name, so that's why I'm not asking you. I want her to know it. That's why I keep bombarding her with questions. I want her to know it. How are
52.4.
what is the amount of solvent? Remember, sit well. Yes, situation affect your learning. You cannot see the board. Wow. And then there's no light here. So what do you do now? Come closer. Come and stand with me. Come here. Bring your chair. Come closer. So what is, we say that this weight of the dry residue, right, is 2.87 It's confusing you. 2.87 grams. I told you that anything here you can answer from whatever you are seeing on the board. So I don't know what I'm looking for in that book. Look at this is 2.87 grams. This is the weight of the what? The what? Residue, right? I now ask, what we agree that this is the maximum we can take, two of us, because this was gotten from the saturated what? Solution. So this is the maximum you can take. Ndusia, what amount of solvent can take this maximum? It's not the solvent that left. It's not what we say yes is. You better get about here. Alright, what's the issue?
I think 52.4.
All you glasses?
Yes.
Are you sure? God bless you. Now, next thing now, 2.4 grams is what we are agreeing. So the amount of solvent that can take this is what? But remember we say that 1 gram of beer. And that solvent is what? Water. 1 gram is what?
1 cm.
1 cm. Good. If 1 gram is 1 cm, what's the implication? That this, we convert this into volume, right? That means 52 point what? Is equal to how many watts? X cm cube, right?
Yes.
That implies that X is what? We cross multiply, right? So X is now 52.4. It's just simply what? 52 point what? Centimeter cube. This is the volume of water or solvent that can take this what? Amount. That can take. Now what it means is this. Can you see the board? Are you sure? Are you okay? Are you sure you're okay? So what it means that 2.87 grams of potassium triosonitrate 5 is the maximum amount of potassium triosonitrate 5 that can dissolve in what? 52.4 cl of water. That's the meaning. Hello? Are you with me? What it means is that 2.87 grams of potassium what? Potassium what? 1295 is the maximum amount in mass of potassium 1295 that can dissolve in what? 52.4 cm cube of what? Water. But it doesn't end there. It doesn't do what? End there. We need to do what? Check we can move it to what? DMQ. Hello? We can move it to what? DMQ. Remember it talks about what? A what? DMQ. Are we together? A what? DMQ. So we can move it to concentration term of mole per what? DMQ. So let's move it to concentration term of mole per what? DMQ. But before we do that, remember the amount. Go to that definition of solubility. The amount, is it only in gram or both in gram and mole? It can be in gram, it can be in what? Right? So that means it can be gram per dm cube or it must be dm cube. That's the basic thing you should know, right? So it should be, because they say in 1 dm cube, right? So it can be in gram per dm cube or mole per what? Dm cube. Now, before we do that, let's find it in gram per dm cube first. If you want to find it in gram per dm cube, we'll convert this to what? 52.4 cm cube to what? Dm cube. Are you together? So if you want to convert 52.4 cm cube to 1 dm cube, remember I told you that 1 dm cube is what? 1000 what? Cm cube. Right? Right? That means 52.4 cm cube is how many dm cube? X. So how many dm cube will 52.4 cm cube be? So if you convert this 52.4 cm cube, is Sepna saying what? 0. What? 524 what? Dm cube. So we have gotten solubility of what? Potassium nitrate in water. So remember the temperature is at what?
Room temperature.
Remember the temperature. Huh? No, now we say that 1 dm cube is equal to 1000 cm cube. And we have gotten the volume. But you know how we got this volume, right? We convert this 2.4 cm cube to dm cube. Simple. When you say that 1 dm cube is 1000 cm cube, convert this 52.4 to what? Dm cube. Is it clear now? Convert it. What did you get? Eh? 0.0 what? 524. Just divide it by 1000. Simple. You got what? 0.4 what? 0.0524 what? Dm cube. This is we have gotten the solubility of what? Potassium nitrate. So what it means is that 2.87 gram of potassium nitrate at room temperature will dissolve, is the maximum that can dissolve in what? 0.0524 dm cube. Let's put it to 1. They say 1 dm cube. Remember, let's put it to 1 dm cube, right? That means we divide 2.87, right? By what? 0. What? Are you with us? 0.0 what? Dm cube. What's the answer? The answer should be in gram per dm cube before it can be what? Either gram per dm cube or mole per dm cube. After we see moving to mole per dm cube, but it must be in per 1 dm cube, right? A 1 dm cube. So what's the answer? 2.87 gram divided by 0.0524. 54 point what?
54.8
gram per dm cube. So this is the solubility of what? Potassium triisonitrate 5. Do you now realize what this means? It means that 54.8 gram of potassium nitrate is the maximum at room temperature. 54.8 gram of potassium nitrate is the maximum mass of potassium nitrate that can dissolve in 1 dm cube of what? Water at room temperature. Is it clear? Is it clear? Now, if you want to, we can move this to what? Mole per dm cube. How do we move this to mole per dm cube? We simply calculate the molar mass of what? Potassium nitrate, right? We just convert this gram to number of moles, simple, to moles. And how do we convert gram to mole? By dividing it with the molar mass, simple. Is it clear? Do you know that one? Are you serious? Good. No, but you did this in it. It's okay. Let's not go there. Know this formula. Number of moles. Anytime they give you something in gram and you want to convert it to mole, what you simply do is this. This one is gram per dm cube. We want to move it to what? Mole per dm. Dm cube is still there. We just convert this gram to what? Mole. And how do we do it? Number of moles. N is not reacting mass over what? Molar mass. This N is what? Number of moles. M is what? Reacting mass. Or the mass, go. M, capital M is the what? Molar mass. So potassium nitrate, we already know the mass of here, which is what? Is now 54.8 gram. We don't know the molar mass. Molar mass is mass of 1 mole of a substance. So molar mass of potassium nitrate. This is the formula for what? Potassium nitrate. To calculate the molar mass, you just add up all the what? Relative atomic mass of all the elements, atoms in the potassium nitrate. Simple. Potassium relative atomic mass is what? 39. Are we together? Potassium is what? 39. This is in the periodic table. Potassium is what? 39. Plus nitrogen is what? 14. Oh yeah. Nitrogen is what? 14. Oxygen is what? 16. Plus 16. But there are 3 oxygen there, right? So 16 times 3, right? Which is what? 48, right? Are you following me? 16 times 3 is what? 48. So plus what? Plus what? 48. So you add up. If you add 39 plus 14 plus 48, the answer is what?
1.1.
So the molar mass of potassium nitrate is what? 101. The unit of molar mass is gram per mole. Put it down. No? Gram per what? Mole. This is the unit of what? Molar mass. So you now use the molar mass of potassium nitrate to divide its what? Mass, right? Gram per what? Mole. If you divide, this gram will cancel gram. Mole will come up. True or false? You are left with what? Divide with 4.8 by 101. What's the answer?
0.54.
So 0.154. So this is what? 0.54 what? Mole. Are we together? This is the number of moles is now 0.54. What it means is that the solubility of potassium nitrate in mole per dm cube is now what? 0.54 what? Mole good per dm cube. Good. You're talking now. Hey, that's my girl. You're talking now. I don't know what you are taking before. Now, it's now what? 0. So, whether it is, everything here is not in line with the definition we gave. So, for potassium nitrate, 54.8 gram per dm cube means that what I want to interpret this, listen to my interpretation. For potassium nitrate, 54.9. So, if you are told that solubility of potassium nitrate is what? 54.8 gram. Are you listening?
Yes.
If you are told that the solubility of potassium nitrate is 54.8 gram per dm cube, what it means is that 54 at room temperature. Remember, this experiment was carried out in what? Room temperature. What it means is that at room temperature, 54.8 gram of potassium nitrate is the maximum weight or mass of potassium nitrate that can dissolve in what? 1 dm cube of water. Simple. That is why you say that this is the what? The solubility of potassium nitrate. Each of in interpreting moles, you can say that this 0.54 mole per dm cube means that 0 at room temperature 0.54 mole of potassium nitrate is the maximum amount of potassium nitrate that can dissolve in what? 1 dm cube of what? Water. This is the solubility. This is what solubility is all about. Remember I told you that solubility is a concentration term. Remember I told you that concentration. Remember I told you that concentration is a what? Sorry. Remember I told you that. Remember I told you that solubility. He doesn't know that we record a lecture. That's why he doesn't know. Now remember I told you that solubility is a concentration what? Term. Isuchiku iye dogaya. Are you sure? Question. I will not be happy to you because I'm going to give you calculation now. Have you seen the calculation we did? This is what solubility is all about. So I'm going to give assignments on calculations in solubility. Enough of it. So you people can use idea of what we did here and solve them. In our next class, you come out one by one and solve it. In our next class on solubility, we'll talk about other aspects of solubility like application of solubility and the other things. But I want to give assignments now. Or is it better I solve one question before we give assignment? What do you think? I should give. You are loaded. Now you want to go which one? Why not the one going to solve a question? You want to go? Or you're loaded already? Which one? You're loaded. Have you tried to have you done this in your school at all? Solubility? Okay, mathematics, it's well. But you now understand the mathematics, right? Good. So let me give assignments. Okay. Assignment number 1. Assignment number 1. When a crystal was added to a clear solution of its salt. When a crystal is added to a clear solution of its salt, the crystal did not dissolve. The crystal did not dissolve. And the solution remained unchanged. And the solution remained unchanged. This showed that the solution was A. This one has options. This showed that the solution was A. Option A. Supersaturated. Option A. Supersaturated. B. Concentrated. C. Unsaturated. D. Saturated. Number 2. A supersaturated solution. A supersaturated solution is said to contain A. As much solute as it can dissolve at that temperature. A. As much solute as it can dissolve at that temperature. B. More solute that it can dissolve at that temperature. B. More solute than it can dissolve at that temperature. C. C. As much solute as it can dissolve at that temperature. As much solute as it can dissolve at that temperature in the presence of undissolved solutes. C. As much solute as it can dissolve at that temperature in the presence of undissolved solutes. D. Option D. Option D. More solute than it can dissolve at that temperature.
You said more solute than it can dissolve.
Yeah, D, right?
No, B.
B. Oh, B, Kenon.
No, it's the same thing with D.
I'm coming. Just keep following, keep writing. I'm not done with the option. There are things I will still call. Option D says more solute than it can dissolve at that temperature in the presence of undissolved solute. More solute than it can dissolve at that temperature in the presence of undissolved solute. Are we together? Huh? Now, number three. A substance S, capital S. A substance S is isomorphous. 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 A substance S is isomorphous with another substance R. A substance S is isomorphous with another substance R. Full stop. When a tiny crystal of S is added into a supersaturated solution. When a tiny crystal of S is added into a supersaturated solution of R, option A, R. Then option A, S dissolves in the solution. Option A, S dissolves in the solution. Option B, crystals of R are precipitated. Option B, crystals of R are precipitated. Option C, there is no observable change. There is no observable change. D, R and S react to generate heat. D, R and S react to generate heat. R and S react to generate heat. R and S react to generate heat. Are we there? Then number 4. Let's do a bit of calculation. Number 4. 12 gram of potassium chlorate. Potassium chlorate, the formula is K. Of course, you know the formula now. You know the formula of potassium chlorate. That's potassium, right? Potassium, right? Also, chlorate, 5%. Just take it out together. KClO3, potassium trioxochlorate. But don't worry, by the time we go into formula, I'll teach you that one. Even though you should know it, but no problem. That's why you are here. You realize that you are lacking in some aspect. That's why I'll teach you. No wahala. So 12 grams of solid potassium chlorate we are added to 40 grams of water. We are added to 40 grams of water and heated to dissolve all the solid. (12 grams of solid potassium chlorate in bracket KClO3 we are added to 40 grams of water and heated to dissolve all the solid. Full stop. As the solution cools, As the solution cools, crystals of potassium chlorate started forming at 66 degrees Celsius. Crystals of potassium chlorate started forming at 66 degrees Celsius. Full stop. The solubility of potassium chlorate at 66 degrees Celsius is therefore A. Which one? Huh? Okay, I should start from the beginning. Are you okay with that too? As the solution cools, crystals of potassium chlorate started forming at 66 degrees Celsius. Full stop. The solubility of potassium chlorate at 66 degrees Celsius is therefore A. 33, B. 10, C. 20, D. 30. C. 20, D. 30. How many questions have we got? Number 5. Number 5. 5 cm cube. 5 cm cube of saturated solution. 5 cm cube of saturated solution of sodium chloride at 30 degrees Celsius gave a careful evaporation. 5 cm cube of saturated solution of sodium chloride at 30 cm cube gave sorry I made a mistake. Just listen and correct anywhere you notice correction. Please correct it in your work. Let me start from the beginning. 5 cm cube of saturated solution of sodium chloride at 30 degrees Celsius gave on careful evaporation, gave on careful evaporation, 1.95 gram of solid salt. 1.95 gram of solid salt. Does this look like the experiment we did? Good. 1.95 gram of what? Solid salt, the solubility of sodium chloride. The solubility of sodium chloride at 30 degrees Celsius. The solubility of sodium chloride at 30 degrees Celsius is A. 5.00 mole per dm cube. 5.00 mole per dm cube. B. 5.67 mole per dm cube. C. 6.00 mole per dm cube. 00 mole per dm cube. D. 6.67 mole per dm cube. 6.67 mole per dm cube. Then open a bracket so you can list the relative atomic mass of the component element that form sodium chloride. Open a bracket. Na, that is sodium. Na is equal to 23. Na is equal to that the relative atomic mass of sodium is what? 23, comma Cl, which is chlorine, is 35.5. Then close the bracket. Number 6. 3.06 gram. 3.06 gram of a sample of potassium triosochlorate 5. This name is the IUPAC name of that potassium chlorate we mentioned. Are we together? Potassium chlorate is the old name, but this is the IUPAC name. The IUPAC name is what? Potassium triosochlorate 5. That is KClO3. So the question says 3.06 gram of a sample of potassium triosochlorate 5, KClO3, was required to make a saturated solution. Was required to make a saturated solution with 10 cm of water. Was required to make a saturated solution with 10 cm of water at 25 degrees Celsius. Was required to make a saturated solution with 10 cm of water at 25 degrees Celsius. Full stop. The solubility of the salt at 25 degrees Celsius is A. A 5.0 mole per dm cube. A 5.0 mole per dm cube. B 3.0 moles per dm cube. B 3.0 moles per dm cube. C 2.5 moles per dm cube. C 2.5 moles per dm cube. Then D 1.0 moles per dm cube. 1.0 moles per dm cube. Are we together? Are we together? Now, number 7. Put your phone light. If you cannot see clearly, put it on. I didn't know that this would be like this. Maybe next time I'll get touch. Put it on so that you can. Let's go. After this question, we'll go. I don't think we may continue. We may set it 6 p.m. because of this was becoming dark. I didn't plan it well. I'm sorry about that. We will not do English again today because of this thing. Are we together? Now, number what? 7. When 50 cm cube of a saturated solution of sugar, when 50 cm cube of a saturated solution of sugar, in brackets, molar mass 3.42 gram per mole. When 50 cm cube of a saturated solution of sugar, in bracket, molar mass 3.42 gram per mole, bracket closes, at 40 degrees Celsius, was evaporated to dryness. At 40 degrees Celsius was evaporated to dryness, 34.2 gram of the dry solid was obtained. 34.2 gram of the dry solid was obtained. The solubility of sugar at 40 degrees Celsius is, the solubility of sugar at 40 degrees Celsius is A, 10.0 moles per dm cube. A, 10.0 moles per dm cube. B, 7.0 moles per dm cube. B, 7.0 moles per dm cube. C, 3.5 moles per dm cube. C, 3.5 moles per dm cube. D, 2.0 moles per dm cube. Are we together? All right. Then number 8. Number 8. Number 8. The solubility in moles per dm cube. The solubility in moles per dm cube of 20 gram of copper sulfate. You know the formula for copper sulfate now, right? Right? Good. CuSO4. Good. The solubility in moles per dm cube of 20 gram of copper sulfate dissolved in 100 gram of water at 180 degrees Celsius is the solubility. Let me say it again. The solubility in moles per dm cube of 20 gram of copper sulfate dissolved in 100 gram of water at 180 degrees Celsius is A, 0.13. A, 0.13. B, 0.25. B, 0.25. C, 1.25. D, 2.00. Now, what number are we entering? Number what? 9. Okay. Number 9. The solubility of copper 2 tetraoxosulfate 6, that is copper sulfate. The solubility of copper 2 tetraoxosulfate 6. The solubility of copper 2 tetraoxosulfate 6, that is copper sulfate, is 75 gram in 100 gram of water at 100 degrees Celsius. Is 75 gram in 100 gram of water at 100 degrees Celsius. Is 75 gram at 100 gram of water. Is 75 gram in 100 gram of water at 100 degrees Celsius. And the 25 gram in 100 gram of water at 30 degrees Celsius. And the 25 gram in 100 gram of water at 30 degrees Celsius. Full stop. What mass of the salt would be crystallized? What mass of the salt will be crystallized? What mass of the salt would crystallize? If 50 gram of copper 2 tetraoxosulfate 6 saturated solution. If 50 gram of copper 2 tetraoxosulfate 6 saturated solution at 100 degrees Celsius, we are cooled to 30 degrees Celsius. What mass, if 50 gram of copper 2 tetraoxosulfate 6 solution saturated at 100 degrees Celsius, we are cooled to 30 degrees Celsius. Option A, 57.5 gram. Option A, 57.5 gram. Option B, 42.9 gram. Option B, 42.9 gram. C, 28.6 gram. C, 28.6 gram. D, 14.3 gram. D, 14.3 gram. Which option are we entering? Which question are we entering now? Last question, right? Question 10. The solubility in moles, number 10, last question for the day. The solubility in moles per dm cube. The solubility in moles per dm cube of 20.2 gram of potassium trioxonitrate 5. This one we worked on. We used for the experiment, KNO3. The solubility in moles per dm cube of 20.2 gram of potassium trioxonitrate 5 dissolved in 100 gram of water. The solubility in moles per dm cube of 20.2 gram of potassium trioxonitrate 5 dissolved in 100 gram of water at room temperature is A, 0.10, B, 0.20, C, 1.00, D, 2.00. Open a bracket to write the relative atomic mass of the component elements of potassium trioxonitrate 5. K, potassium, is 39. Comma, O for oxygen is 16. Comma, N for nitrogen is 14. Bracket closes. Bracket closes. Any question? Any question? No question. I think we have. We can continue, Shay. We can continue. Let me solve one question. Let me just solve one question on this. With that, I think to prepare for assignments. Okay? Let me solve one question. Let's solve this question. Let's solve this question. Let me see if I can see a question from this textbook. Let's solve this question. At least with that, I'll prepare a soft landing for you to really now solve it. As many questions as you can. 298, page 298. Let's solve this question in this textbook. Page 298. Okay, let me see. Okay, look at this question. Put it down. Let's solve it. Okay? If 12.2 gram of lead 2 triisonitrate lead 2 triisonitrate if 12.2 gram of lead 2 triisonitrate 5 were dissolved in 21 gram of distilled water. If 12.2 gram of lead 2 triisonitrate 5 were dissolved in 21 gram of distilled water at 20 degrees Celsius. If 12.2 gram of lead 2 triisonitrate 5 were dissolved in 21 gram of distilled water at 20 degrees Celsius, calculate the solubility of the solutes in mole per dm cube. Calculate the solubility of the solutes in mole per dm cube. Calculate the solubility of the solutes in mole per dm cube. A mole per dm cube. Okay, let's solve this question. The question says if 12, so the weight of the lead 2 triisonitrate, see the formula, lead 2. This is lead. Lead has 2 positive ions, so it will cross here. This is lead 2 triisonitrate 5. Okay? This is lead 2 triisonitrate 5. Pb in bracket NO3 bracket closes, then 2 subscript outside. This is lead 2 triisonitrate 5. Now the question is if 12.2 gram of this compound we are dissolved in 21 gram of distilled water. In 21 gram of distilled water, they say we should find the solubility in mole per dm cube. Now look up. What do we define solubility as? The maximum amount of the solute that 1 dm cube of a solvent can take, right? At a particular what? Temperature. Now this is solute. The maximum this can take, 1 dm cube can take. Am I concluding? We are told that this 12.2 gram, 12 gram of this was dissolved in what? 21 gram of what? Distilled water. 21 gram of what? Distilled water. Now, as here, what is the what? The what? The solubility, right? Now, first of all, let's find, we are told to find it in mole, right? Let's convert this weight to mole. How do we do that? By dividing it with what? With what? With what? The what? The good. So number of moles of lead, number of moles of lead 2 triosonite that were dissolved is what? Mass of lead 2 triosonite divided by the what? Molar mass of what? So number of moles of this, number of moles of this of lead 2 triosonite dissolved in 21 gram of what? Water. They say water is equal to number of moles, right? 12.2 gram over what? What is the molar mass of lead 2? Let's calculate it. Lead has the component element of lead 2 2005 are lead, nitrogen, and what? Oxygen. Lead has, what is the atomic mass of lead? You tell us. Tell us. Huh? Tell us also. Huh? Huh? No idea. Lead is 207 because 20 what? 7 plus nitrogen is what? You should know all these things. Please study all these things. Please. Even you. Plus what?
14.
Oxygen, how many? Okay, sorry. Both oxygen and nitrogen are enclosed together. I hope you know. But within oxygen inside is 3, right? So we have 16 times what? Or by what? 2. Let's go. This is 207, right? Plus this times 16 times 3 is what? 48. 48 plus 14 is what? 48 plus 14 is what? Fast. 48 plus 14 is what? Fast.
62.
I'm coming. 48 plus 14 is what? Is what? 62. Then 62 times 2 is what? 1 what? 124. Are you sure? Check well. I'm coming. I want to confirm something. One word, sorry. 124. Let's continue. 124. Because here is 14 plus 48, 62, right? Times 2, 1 what? Then add 124 to 207 is what? 3 what? 331. Right? Right?
Yes.
So now that means, remember molar mass in grams per mole. Remember? So the number of moles of lead 2 is now 2.2 gram divided by what? 3.31 gram per what? So what's the answer?
Gram will cancel.
Good. What's the answer? More will come up. What's the answer? Just do 12.2 divided by 331. 0. What?
0.04.
Just
0.036.
3 what?
6.
Hey, 36 what?
8.
You waiting me at 2.4. Hey, it's too much. It should be 0.03 what? 7. It's okay. Okay. Be careful the way you do your pronunciation, okay, Biko? So this is 0.037 watts. Unit is what?
Mole per dm.
See? What are you saying? Number of moles per dm cube. What are you calculating now?
Number of moles.
Is it mole per dm cube?
Number number of mole.
Good, moles. So this is 0.037 what? Mole. What? 0.37 what? Moles. Are we there? Now we have gotten the number of moles of lead 2,385 that will dissolve in what? 21 gram of what? Water. Now let's go to the solvent. Now we have gotten the what? Solute. Let's go to the what? Solvent. Are we together? Let's go to what? Solvent. The solvent is 21 gram of water. Remember I told you that 1 gram of water is what?
1 centimeter
of water. So if 1 gram of water is equal to 1 cm cube of water, that means 21 gram of water is what? 21 what? Cm cube of what? Water. Are we together? But solubility is not in one. The solubility is not measured in cm cube of 121 cm cube. We move it to what? 1 dm cube, right? True or false? Now, 1 dm cube is how many cm cube? So 1 dm cube is 1,000 what? Cm cube. So we move this cm cube to what? Dm cube, right? Right? So that means 21 cm cube is how many dm cube? 0 point what?
0.021.
That means 21 cm cube over what? 1,000 what? Cm cube times what? 1 dm cube. The answer is what? 0.021 what? What? Dm cube. So this is the volume in what? Dm cube. Are we together? Now, see the meaning of this thing. Are we together? Are you with us? Look up, please. See the meaning of this. That 0.037 mole of potassium of lead 2,385 dissolves in what? 0.021 what? Dm cube of water. Are we together? So how many moles of lead 2,385 will dissolve in what? Dissolve in what? 1 what? Dm cube. Are we together? Are we together? So X is now what? 0.0 what? 37 moles times what? 0.021 what? Dm cube over what? 1 what? Dm cube. Dm cube will cancel Dm cube. Okay? So how many moles will dissolve in 1 Dm cube? Just multiply. Sorry. Forgive me. This should be 1. 1 should be here. Sorry. 1 what? 1 what? Over what? Sorry. 0.021 what? Dm cube. Dm cube will cancel what? Dm cube. Then divide 0.037 by 0.021.
1.76.
So that means 1.62 moles of what? Lead 2-triazonitrate will do what? Dissolve in what? 1 dm cube of what? Distilled water at 20 degrees Celsius. What temperature is what? At 20 what? Degrees Celsius. What it means is that the concentration of this lead 2-triazonitrate is now 1.72 mole per watt. Mole per watt. Mole per watt? Dm cube. 1. So it's the solubility of lead 2-triazonitrate is 1.762 mole per watt Dm cube. Mole per watt Dm cube. I think we can stop here for today. With this idea now, we can at least if not for anything, those questions that look like this one, you can solve them. 3 of us. So try it out. Let's see. In our next class, the one that is you weren't able to solve, and we don't know why you weren't able to solve it. Okay. So, any question? Any question? All right. See you next week, Tuesday. Oh, sorry, Monday. Sorry. Okay. You know where? What I so you be another board. You. Yeah. All right.